Okay, so this is the PowerPoint that's really going to go through the nuts and bolts of what we're doing to make it easier for you to see. So the one that it says using StatCrunch, that'll be the one you'll look at for how do I do the homework problems, for example. So suppose you want to estimate the mean number of hours college students are working per week. This is the same question, so you don't have to understand a new question. You could take a survey of 200 students and ask them how many hours they worked last week. And suppose you calculate a sample mean, so an X bar of 24.8, and a sample standard deviation of 1.2. Construct a 95% confidence interval for the mean number of hours worked by all students. Express the answer with 3 decimal places. So again, you have sample data, but we want to construct a confidence interval from that sample data. So gather your information. These are the 4 things you're going to need. You're going to need to know, what's my confidence level that I need first? What's my sample size? What's my sample mean? And what's my sample standard deviation? And so for you, those things will all be part of the problem. Okay, so this is what it looks like. What we're going to be using is called the t-statistic. We're using the t-statistic. So it's t-stats, 1 sample with summary. You're given 3 blanks to fill out. What is the sample mean? X bar. What is the sample standard deviation? S. And what is the sample size? N. You have 2 possible things to click on. You want to click on the one that says confidence interval for the mean and put in the level. So 95% or whatever as a decimal. Again, all these are going to be in the PowerPoint's already there for you, and then this is going to be added as a screenshot. Oh, let's get rid of that nonsense. Okay. So this is what your output's going to look like. Let's go through everything. So they remind you that you're looking for the 95% confidence interval for the mean mu. This was your sample mean, your X bar. We are not using standard error. It is not standard deviation. Okay, not standard deviation, it's something else. And we're not using this DF. We're just using the lower limit and the upper limit. So our solution is we are 95% confident that the population mean is between 24.633 and 24.967. So it's actually fairly easy to do. It's just hard to understand a little bit until you've done it a few times. Right? Another example. A poll asked 1,006 Americans during the past year, how many books did you read, either all or part of the way through? Results of the survey were that 1,006 participants of the survey read a mean of 13.4 books with a standard deviation of 16.6 books. Construct a 99% confidence interval for the mean number of books all Americans read in the preceding year. So first of all, it's a 99% confidence interval we're looking for. And we're looking at for the mean, because in the next section we'll be looking at the proportion. So you want to know it's a mean. 1,006 is our sample size n. And they had a mean of 13.4, that's our X bar, and a sample standard deviation of 16.6, and that is our S. Any questions on where I got any of that from? So gathering your information, 99% confidence interval, N is 1006, X bar is 13.4, and S is 16.6. Solution, we have a one sample T summary, and I've put in the sample mean, the sample standard deviation, and my sample size, and changed it to a 99% confidence interval. So I get my lower limit and upper limit here. So we are 99% confident that the population mean of the number of books read by all Americans is between 12.049 and 14.751. We're going to generally round it to 3 decimal places unless we're asked for something else. Any questions? Okay. The last thing that is part of this section is looking at determining what sample size you should take. Now, doing surveys can be very expensive. So when you hire someone to do the survey, you want to tell them how big a sample they need to do. And you want to do it so you get the size confidence interval you're looking for, so that you can say, well, I want it within so many, the mean, within so many units of the mean. So this is a method to figure out what sample size I need before you actually start surveying. Because if you finish and it's not small enough, then you have to send people out again. So for example, a researcher wants to determine the mean of a population with a sample size estimate of S equals 4.5. So you have to have an estimate of the standard deviation when you're working with the mean. So you're going to be given this S equals 4.5, which is our sample standard deviation. Determine the sample size needed to find a 95% confidence interval within 2. So this within is a clue that the margin of error needs to be 2. So there's 3 numbers you're going to need: the 4.5 for the standard deviation, a 95% confidence interval, and the margin of error 2. Oops. So the example asks for a confidence interval to fall within 2 units of the sample mean. This means that they want the margin of error to be 2, but the width of the, excuse me, the width of the confidence interval is what the problem StatCrunch asks for. So remember that our X bar sits in the middle with a margin of error on either side that makes up the width. So the width is twice the margin of error. That's the key to remember when you're doing the problem. If you're getting the wrong answer, check that you actually use the width and not the margin of error. The way to find it is look for that word within. That's a clue. So here's how we use StatCrunch to do that. Key is that we're not using tstat for this. Tstat is not the way to go. We're going to be using what they call ZStat. So we're going to do stat, ZStat, which falls right above tstat. One sample and with sample size, which is compare the sample, find me the sample size when I have the with or vice versa. So we put in the confidence level, 95%, the standard deviation of 4.5, and the width of 4, and leave the sample size blank. And when you click compute, it finds you the sample size. Now notice this number changes slightly. It gets a little bit smaller once we've clicked compute. That's because it's rounding that sample size up to a whole number for you. Okay. So again, if you want to find the confidence interval for the mean, I'm going to use the tstat. If I want to find the sample size for the mean, whoops, too many P's, sample size for the mean, I'm going to use ZStat. Okay, so that's the difference between when we use those two things.